The object that we have investigated for this task is kain kebat. Kain kebat is a beautifully patterned skirt. It also known as a Kantu people of Borneo luxurious ceremonial clothing. Kain kebat is a ritual textile that weavers among the Kantu and surrounding people create. Kain kebat and our culture. Iban women typically dress in kain kebat for ceremonial occasions, especially when performing ritual tasks like placing out food offering for the gods and spirit and dyeing the thread used in textile weaving. The origin of kain kebat. Kain kebat has a classic instance of essentially the same basic design with a single genesis emerging in Kalimantan hundreds of years before the Iban migrated into Sarawak.
Usage and function of kain kebat. Kain kebat is usually worn by Iban community. This fabric is also known to be one of luxury clothing commonly used during grand ceremonies. Kain kebat are worn as formal attire by women on important occasions, especially while performing ritual activity such as setting out food offerings for the gods and spirit, dyeing the threads of weaving textile. The female lady in Iban communities usually wears the nepan during the event called Kuman Gawai. Nepan Indo-Iban is equivalent to English translation as Iban female's traditional costume. An attractive and meaningful design pattern of nepan is made using the woven weaving technique by Iban women. This uniqueness of this dress is not only in its motif but it also accessories such as jewelry from head to toe. Then from the midsection of the lower part of the body, the traditional kain kebat is worn. Next is size of kain kebat. This kain kebat is narrow and its length is only about until knee. The Iban women wear the dress consisting of kain kebat, mari empang, which is a chest adornment, the sugu tinggi headdress, and the other silver ornaments such as coin belt and bangles. This fabric is usually the same as puah kumbu, which is decorated with colorful strips and various geometric patterns and color with red brick and yellow. For these studies, due to the popular one, we will emphasize the normal size of kain kebat. It has 105 cm of height and 55 cm of width. The diagram shows one of example of kain kebat that we use. As we know, kain kebat has various of geometric patterns and colorful strips.
Geometrical shapes. There are three types of geometrical shapes found in kain kebat, which is rectangle, rhombus, and isosceles triangle. Rectangle. A rectangle is a type of quadrilateral that has its parallel sides equal to each other and all the four vertices are equal to 90 degrees. Hence, it is also called an equiangular quadrilateral. Since the opposite sides are equal and parallel in the rectangle, therefore, it also can be termed as a parallelogram. Rhombus. A rhombus is a special case of a parallelogram. In a rhombus, opposite sides are parallel and the opposite angle are equal. Moreover, all the sides of a rhombus are equal in length and the diagonal bisect each other at right angle. The rhombus is also called a diamond or rhombus diamond. The plural form of a rhombus is rhombi or rhombuses. Isosceles triangle. An isosceles triangle is a triangle that has two equal sides. So, the two angles opposite to the two equal sides are equal. In other words, we can say that an isosceles triangle is a triangle which has two congruent sides.
And now, we are going to talk about the concept of the geometrical shapes. Kain kebat consists of an isosceles triangle and rhombus shape on it, and the shape of kain kebat itself is rectangle. For a rectangle, it has 4 sides and 4 vertices. Opposite sides are equal, opposite sides are parallel, all 4 angles are right angles, and the diagonals are equal and bisect to each other. It has base 1.2 meter and height 0.6 meter. And we can actually find the angle of each vertices by using the formula n, which is the number of vertices, minus 2 times 180 degree divided by n. And for the angle for each vertices, we will get 90 degree. And for the area, we can multiply base and height, and we will get 0.72 meters square. In an isosceles triangle, the two sides of equal length are the legs. The third side is the base. The point at which the two legs meet is vertex of the triangle. The angle formed by the legs, which is opposite of the base, is the vertex angle, and the two remaining angles are the base angles. From the diagram, H is referring to the altitude, which is 6 cm. B is referring to the base, which is 10 cm, and A is referring to the hypotenuse. Then, we can find the value of A by using the formula of Pythagorean theorem, which is A squared equals to H squared plus B squared. Then, after doing some calculation, we will get A equals to 11.66 cm. For the perimeter, we can find it by adding all the value of the sides. For this isosceles triangle, the perimeter is 29.32 cm. Next, the sum of the interior angle of the isosceles triangle is 180 degree. If we refer to the third diagram, we can find the interior angle by adding alpha plus beta. And as we learned in geometry, base angle for isosceles triangle are congruent, so we can know angle y equals to angle z. And to find angle x, we can actually calculate 180 degree minus the value of angle y and angle z. Next, we can find the area of the isosceles triangle by using the formula, which is 1/2 times b times h. Then we will get 30 cm square. The area of the isosceles triangle also can be calculated by using the area of right angle triangle formula, which is 2 times 1/2 times b/2 times h, and we will get the same answer, which is 30 cm square. Next is the shape of rhombus. A rhombus has 4 congruent sides. Opposite sides are equal, opposite angles are equal, diagonals are perpendicular and bisect to each other, and lastly, the consecutive angles are supplementary. By referring to the diagram, the value of dB is 2 cm and AC is 3 cm. And from the value, we can find the angle of the rhombus. To find angle D, we can multiply 2 with arctan3/2. Then we will also get the value of angle D because it is the opposite angle. So the value of both angles, which is angle D and angle B, are 112.62 degree. We also can find the value of angle A and C by subtracting 180 degree with the value of angle D or B. It is because consecutive angles are supplementary. Therefore, we will get a 67.38 degree. Next, we can find the area by multiplying AC with dB/2. That means we have to multiply 2 with 3/2, and we will get 3 cm square.
Relation the motifs and the pattern with the concept of transformation. Motif. Motifs are part of an image that may be arranged and repeated in a variety of ways to produce various patterns. A pattern, motif, or design represent abstract non-representational shapes such as lines, triangle, rectangle, circle, ellipse, and polygons. Thus, a rhombus and isosceles triangle is our motif from the Cain-Quebec. Rhombus. A rhombus is formed when 2 or 4 triangles are joined together. To create the whole rhombus, the triangle must go through the transformation process. The rhombus can be formed from the reflection between 2 or 4 triangles. A reflection is a transformation representing a flip of a figure in a line. So, image is congruent to the object when reflecting a figure in a line or a point. There are three examples of reflection where the first one is the reflection on x-axis, second is reflection on y-axis, and the last one is reflection on y equal to x line. A reflection maps every point of a figure to an image across a fixed line. A line of reflection is the name given to the fixed line. The example of fixed line is from the example of reflection is x-axis, y-axis, and line y equal x. Pattern. The pattern that has been derived from kain kebat is a repetitive pattern with motif of the same size. A geometric pattern is a kind of pattern from the geometric shapes and typically repeated like a carving design on the wall. To create the complete pattern, rhombus must undergo the transformation process. Isosceles triangle. When two right-angled triangles are combined together, then it will form an isosceles triangle. In order to create a complete isosceles triangle, the right-angled triangle must be transformed where the right-angled triangle should go through the transformation process. The reflection between two right-angled triangles can create the isosceles triangle. A reflection is a transformation representing a flip of a figure in a line. So image is congruent to the object when reflecting a figure in a line or in a point. There are two examples of reflection where the first one is the reflection on x-axis and second is reflection on y-axis. A reflection maps every point of a figure to an image across a fixed line. A line of reflection is the name given to the fixed line. The example of the fixed line is from the example of reflection which is x-axis and y-axis. Pattern. The pattern that has been derived from kain kebat is a repetitive pattern with the motif of the same size. A geometric pattern is a kind of pattern from the geometric shapes and typically repeated like a carving design on the woods. To create the complete pattern, an isosceles triangle must undergo the transformation process.
For a summary and conclusion that we know from part A is kain kebat is a unique costume or attire with a specific function and play important role in some event. This kind of clothing is very important for some ethnic like Iban ethnic in Sarawak. This kain kebat is very special as it is only used in important ceremonies like ritual ceremonies and mostly for various religious ceremonies. From part B, we know that kain kebat has a rectangle base shape and consists of few types of geometrical shape. In this kain kebat, the element of image of the motif is arranged and repeated in different way in order to create different type of pattern and make this kain kebat look more beautiful and special. Overall, we can conclude that kain kebat is our country's unknown treasure for the unsung places, and we need to be proud of its speciality. Generally, the art in our culture is mostly based on geometrical concept. So by looking at kain kebat, we can apply the knowledge of geometrical that we learn in this course to make elaboration of the shape of its pattern such as rectangle, rhombus, and isosceles triangle.